discuss some of the entrance questions from the chapter Thermodynamics. Today we are going to continue those questions. I think last class we discussed nearly 15 questions. So today I'll start with question number 16. Okay. So question number 16. Match list 1 equations and list 2 type of process and select the correct option. So list 1 and list 2 are given. We have to match them correctly. So list 1 contain so many equations and list 2 contain process. So we have to match list 1 and list 2. So I'll start I'll start with A. Okay. Now before discussing this question, these 3 questions are from next chapter, that is equilibrium. So these 3 questions are from next chapter, equilibrium. Anyway, I'll give some idea, brief idea regarding these 3 topics. Okay. Anyway, these 3 are from next chapter, equilibrium. Now, what is Kp? Kp means if the reactant, let R be the reactant. Reactant and product are in equilibrium. They are in equilibrium. Equilibrium means they are like amount of reactant and product does not change with time. That is known as equilibrium. If they are in equilibrium. Okay. Now at equilibrium, if the reactant and product are at equilibrium, then the ratio of pressure of product by pressure of reactant is known as Kp. For example, if a reaction attain equilibrium, R and P are at equilibrium. Equilibrium means all of them become constant. Temperature constant, pressure constant, volume constant, concentration constant, everything become constant. That condition is known as equilibrium. Okay. So if everything attain equilibrium condition, everything remains constant, that condition is known as equilibrium. For a reaction R giving P, all the properties, pressure, temperature, volume, concentration, everything become constant. That means reactant convert to product. That is, this reaction is at equilibrium. Now, at equilibrium, ratio of pressure of product by pressure of reactant is known as Kp. Now, what is Qp? Qp means if reaction is not at equilibrium, if the reaction is not at equilibrium, then at that time, ratio of pressure of product and pressure of reactant is known as Qp. Okay, Qp. Anyway, you will learn this in next chapter in detail. I'll give a brief idea. So, if a reaction attain equilibrium, equilibrium means all the properties, temperature, pressure, volume, concentration, everything become constant. That condition is known as equilibrium. At equilibrium, ratio of pressure of product and pressure of reactant is known as Kp. And if reaction is not at equilibrium, before attaining equilibrium, the reaction not attained equilibrium, before attaining equilibrium, the ratio of pressure of product and pressure of reactant is known as Qp. I think it's clear. Here, from this equation, from this we can understand that Qp is directly proportional to pressure of product. Qp is directly proportional to pressure of, you can, from this equation we can learn that Qp is directly proportional to pressure of product. That means Qp increases means pressure of product increases, that indicate amount of pressure is higher. Qp increases means here Qp and pressure of product. Okay, not consider this equation, please don't consider this equation, please consider this equation. When reaction is not at equilibrium, the ratio of pressure of product and pressure of reactant is known as Qp. Now from this equation we can see that Qp is directly proportional to pressure of product. Now if Qp value increases, pressure of product increases, and that will be possible if the amount of product is greater. If amount of product is greater, then their pressure will be higher, right? For higher amount of concentrated product, let this be the product. Here pressure will be high only if more amount of products are formed. If product is less means pressure will be low, obviously. So pressure high means, pressure of product high means concentration, amount of product is high. Okay. At the same time, if Qp value less indicate pressure of product less, amount of product less. Okay. Now, here Kp is less than Qp. Qp is less. This equation indicate that Qp is less. So Qp less means product less, Pressure of product less. Pressure of product means less means amount of product less. Amount of product less. If amount of product is less, then the reactant will spontaneously, it will change us to product. If amount of product less means reactant will convert to product. Right? If amount of product less, here QP is less, QP less means pressure of product less. Pressure of product less means, obviously, if product, let this be the product, let this be the reactant. If amount of product less means reactant will change us to product to become equilibrium. Okay, so it will change us to product spontaneously without any help. It will change us to product. So this equation indicates that reaction is spontaneous. So A is 4. I think it's clear. Now, next one, C. Kp is equal to Qp. What is Kp? Kp is the ratio of pressure of product and pressure of reactant at equilibrium. If Kp is equal to Qp, that indicate Qp become equal to Kp. That indicate reaction is at equilibrium. So Qp is equal, Kp is equal to Qp means Qp is equal to Kp. Kp is at equilibrium. That means reaction is at equilibrium. So C 3. Sorry, not 3, 2. C 2. Now, so these two, A and C, you will study in next chapter. And B. This equation is also in next chapter, that is in equilibrium. Anyway, I will discuss that equation. Now, there is a relationship between delta G, change in Gibbs free energy, delta G0, change in Gibbs free energy at standard state, and Q. You can write as QP or Q. Okay. So there is a relationship between delta G, change in Gibbs free energy, delta G0, change in Gibbs free energy at standard state, and Q. The relation is delta G is equal to delta G0 plus RT ln Q. This is the relationship between delta G, delta G0 and Q. Delta G is equal to delta G0 plus RT ln Q. Now here they are given that delta G0 is less than RT ln Q. Delta G0 is less than RT ln Q. That means if RT ln Q is 5, let it be 5. Okay, I am taking a number. Let it be 5. Then it will be less than 5. Let it be 2. What is 2 plus 5? 7. So delta G value will be positive because delta G0 is less than RT ln Q. If RT ln Q, you can consider a number. If the value of RT ln Q be 5, so this is less than 5, you can take 2. What is 2 plus 5? 7. Delta G will be positive. That means delta G positive value indicate non-spontaneous process, right? So B 1. Now remaining D3. D3. D is 3. I think you know this one. D3. I think you know this one. For example, I'll discuss that one. According to Gibbs equation, delta G is equal to delta H minus T delta S. Here delta G H is endothermic. Delta H is positive. So delta G is equal to delta H is positive minus T delta S. So delta G will be negative only if delta H less than T delta S. Or you can write T delta S greater than delta H. If T delta H is greater, if it is greater than delta H, then delta G value will be negative, because if H value is 2 and T delta S is 3, what is 2 minus 3? You will get minus 1. So if T delta S is greater than delta H, then delta G value will be negative. Or you can write T greater than delta H by delta S. If I am taking this delta S here, T greater than delta H by delta S. T greater than delta H by delta S. Delta H value positive, endothermic, and reaction is spontaneous if T delta is greater than delta H or T is greater than delta H by delta S. So answer is option A4, B1, C2 and D1. I have to find the answer. Answer option A4, B1, C2, D3. Answer option C or answer option 3. 3 is the right answer. I think it's clear. Moving on to question number 70. Then question number 70. 3 moles of ideal gas expand spontaneously into vacuum. The work done will be. So, a gas, an ideal gas expands in vacuum. An ideal gas expands in vacuum. Okay, I think we have already discussed this one. Under vacuum condition, external pressure is equal to 0, right? Those expansions are known as free expansion. Expansion in vacuum. Under vacuum condition, external pressure is equal to 0, and that expansion is known as free expansion. Now for free expansion, that is expansion in vacuum, irrespective of the nature of the work, whether it's irreversible or reversible, or isothermal reversible work, irrespective of the nature of the work, for free expansion, that is expansion in vacuum, irrespective of the nature of the work, whether it's irreversible work or isothermal reversible work, value of work will be equal to 0. Okay, so answer is option 4, 0. I think it's clear. Moving on to question number 18. For evaporation of water at 1 atmosphere pressure, the value of delta H and delta S are 40.63 kilojoules per mole and 108.8 joules Kelvin inverse mole inverse respectively. The temperature when gives free energy for the transformation will be equal to 0 is. So here delta H value is given. Delta H is 40.63 kilojoules per mole and delta S value is given. Delta S value is 108.8 joules Kelvin inverse mole inverse. Now here delta S is expressed in joules and delta H is expressed in kilojoules. So you have to convert kilojoules to joules, which is equal to 40.63 into 10 raised to 3 joules per mole, right? Now here delta G value is given, it is equal to 0. Delta G value is equal to 0, it's given there. So according to Gibbs equation, delta G is equal to delta H minus T delta S. So delta G is equal to 0. Delta G is equal to 0 is equal to delta H minus T delta S. I am taking the T delta S to this side. So T delta S is equal to delta H. Taking minus T delta S to this side. So plus T delta S is equal to delta H. T is equal to delta H by delta S. What is delta H? 40.63 into 10 raised to 3 and delta S is 108.8. Now if you divide this number by this number, you will get nearly 373.4 Kelvin. 373.4 Kelvin. When you divide this number by delta H by delta S, you will get nearly 373.4 Kelvin. Answer option 3. I think it's clear. Answer option 3. 3 is the right answer. Moving on to question number 19. The following two reactions are known. Fe2O3 plus 3CO giving 2Fe plus 3CO2, delta H value is minus 26.8 kilojoules, and FeO plus CO giving Fe plus CO2 gas and delta H value is minus 16.5 kilojoules. The value of delta H for the following reaction is. So we have to calculate delta H for the following reaction, and that reaction is Fe2O3 solid plus CO gas giving 2FeO solid plus CO2 gas, right? Now we have to calculate enthalpy of this reaction. And two reactions are given. Fe2O3 plus 3CO giving 2Fe plus 3CO2. Again, this value is minus 26.8 kilojoules. And the second equation, FeO plus CO gas, FeO plus CO giving Fe plus CO2, and delta H value is given minus 16.5 kilojoules. Now we have to calculate enthalpy of this equation, enthalpy change of this equation. Two other equations are given. Okay, from these two equations you have to calculate enthalpy of this equation. From these two equations we have to calculate enthalpy of this equation. So I am going to do this one. Let it be equation 1 and let this be equation 2. And this be equation 3. Let this be equation 3. Okay, this is equation 1. This one is equation 2. And the above equation is equation 3. Now we have to calculate delta H value of equation 3. Now, equation 3 contains Fe2O3. Yes, it is there in equation 1. Equation 3 contains CO. It is there in two equations. Equation 3 contains FeO, and FeO is present in second equation. And equation third contains CO2. Fe is not there in equation 3. Fe is not there. In both the equation, Fe is not there. Like third equation, Fe is not there, but here both the equation contain Fe. So we don't want Fe in our third equation. So what I am going to do is, I have to cancel out Fe. Here there is only one Fe, here there are two Fe. So I am going to multiply. Second equation into 2. So we will get 2 FeO, 2 CO, 2 Fe, 2 CO2, and minus 16.5 into 2. You have to multiply this value with 2. Because I don't want Fe in third equation. In first equation and second equation there are Fe's. So I have to cancel, or we have to cancel out Fe's. Then only we will get this equation from these two. So I am going to multiply with 2. Okay. Now I am going to write first equation minus 2 into second equation. So already we have multiplied with 2. Now we have to subtract this equation from first equation. So this will be minus, 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 and this will become plus. 2Fe minus 2Fe plus 2Fe cancel each other, remaining Fe2O3, 3CO minus 2CO, you will get CO, and there is one minus 2Fe here, minus 2FeO given 3CO2 minus 2CO2, you will get CO2, right? Now I am taking this minus 2FeO to this side, so you will get Fe2O3 plus CO giving CO2 plus 2FeO. I think we got this equation. This is the third equation. Fe2O3 plus CO giving CO2 plus 2FeO. We got the third equation, right? Now here we multiply equation 2 into second equation into 2. Then we subtract this from equation 1. So here delta H value is, first you have to multiply 16.5 into 2, 16 into 2, you will get 32, minus 5 into 2, 33, so 33 kilojoules, right? Okay, here remaining 26.8, right? This will come up, actually it is minus, but when you subtract here, minus, 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 this will become plus. Now when you add these two, minus 26.8 plus 33 kilojoules, you will get delta H as, I think it's nearly 6.2 something, right? It is nearly 6.2 something, 6.2 kilojoules. So we have to find, I don't know whether this answer is correct or not, 6.2 kilojoules, answer option 4, 6.2 kilojoules. I think it's clear. Okay, we've multiplied 2 with second equation, we got a value, then we have to subtract second equation from first equation. So this will become minus, 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 this will become plus. Actually this is minus, when we subtract this will become plus. So 26.8 plus 66.5 into 2, remaining you will get 6.2. So this is the enthalpy value, 6.2 kilojoules plus 6.2 kilojoules, answer option 4. I think it's clear. Moving on to next question, question number 20. The value of delta H and delta S for the reaction C graphite plus CO2 gas giving 2CO gas are 170 kilojoules and 170 joules Kelvin inverse respectively. The reaction will be spontaneous at what temperature? So we have to calculate temperature. So delta H value is given, it is 170 kilojoules per mole, and delta S value is 170 joules Kelvin inverse. Here delta S is expressed in kilojoules, so we have to convert kilojoules to joules. So we will get 170 into 10 raised to 3 joules. Now they have given that to make the reaction spontaneous, what is the value of temperature? According to Gibbs equation, delta G is equal to delta H minus T delta S, and to make reaction spontaneous, delta G value should be negative, because delta G value will be equal to negative for spontaneous reaction. For spontaneous reaction, delta G value is negative. So according to Gibbs equation, delta G is equal to delta H minus T delta S, and they have given that to make this equation spontaneous, what is the value of temperature? So we can write delta H minus T delta S less than 0. Negative value means less than 0. So if delta H minus T delta S is less than 0, negative, then the reaction is spontaneous. So we can write delta H minus T delta S less than 0. Less than 0 indicate negative, spontaneous. Okay, so I am taking this T delta S to this side. I am taking T delta S to this side. So delta H less than T delta S, right? So what will be the value of T? T will be greater than delta H by delta S. Or we can write like this. T is delta H by delta S less than T, or we can write T greater than delta H by delta S. I think it's clear till here. According to Gibbs equation, delta G is equal to delta H minus T delta S. They have given that the reaction, to make the reaction spontaneous, the value of temperature will be. So if the reaction is spontaneous, delta G value is negative. So we can write negative, that is less than 0. This value will be less than 0. I am taking T delta S to this side. So delta H will be less than T delta S. So T will be, or delta H by, I am taking delta S to this side. Delta H by delta S less than T, or T greater than delta H by delta S. I think it's clear. So T is greater than, what is the value of delta H? 170 into 10 raised to 3 joules divided by delta S 170 into 170 joules per Kelvin. 170 will cancel, 10 raised to 3 joules, sorry 10 raised to 3, taking Kelvin outside, okay. So temperature is 10 raised to 3 Kelvin. So temperature should be greater than 10 raised to 3 Kelvin, that is 1000 Kelvin. So answer it's option. Answer is option greater than 1000. Answer option 2, 110, greater than 1000. We will get delta H value greater than 1000. Greater than 1000 means all other values are less than 1000. 7, 10, 5, 10, 9, 10. Only option 2, greater than 1000. 10 raised to 3 Kelvin means greater than 1000. So if temperature is greater than 1000, in option 2 it is given 1110, which is greater than 1000 Kelvin. At that temperature, the reaction will be spontaneous. At that temperature, reaction will be spontaneous. I think it's clear. Moving on to next question, question number 21. From the following bond energy values, HH bond energy is given, C double bond C bond energy is given, CC single bond energy is given, CH bond energy is given. Calculate the enthalpy of reaction. So we have to calculate the enthalpy of reaction, and reaction is C double bond C, H, 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 H. Ethene react with hydrogen H2, giving C, C, H, 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 H. They have given HH. So ethene react with HH, and these two HH will add here to form this one. We have to calculate enthalpy of reaction. Now, here bond enthalpies are given. Bond energy means it's bond enthalpy. Now, what is the equation to calculate enthalpy of reaction if bond enthalpies are given? What is the equation to calculate enthalpy of reaction if bond enthalpies are given? Enthalpy of reaction is equal to bond enthalpy of reactant minus bond enthalpy of product. So if enthalpy of reaction, to calculate enthalpy of reaction from bond enthalpy, this is the equation. Enthalpy of reaction is equal to bond enthalpy of reactant minus bond enthalpy of product. Now here, first we have to calculate bond enthalpy of reactant. First we have to calculate bond enthalpy of reactant. Now, how many C double bonds here? These two are reactant and this one is product. This is the product. So, bond enthalpy of reactant. First we can calculate bond enthalpy of reactant. Bond enthalpy of reactant. Reactant contain one CC bond. One bond enthalpy of C double bond C. Then CH bond. How many CH bond? 1, 2, 3, 4. Plus 4 bond enthalpy of CH bond plus CC bond, CH, 4 CH bond plus 1 HH bond. This one is also reactant. These two are reactant. It contains one HH bond. So 1 bond enthalpy of HH bond. These are the bond enthalpy of reactant. So 1 bond enthalpy of CC bond value is 606.10 plus 4 into bond enthalpy of CH bond. CH bond value is 410.50. It's 410. CH bond value is 410.50 plus 1 bond enthalpy of HH. There is only one HH bond. 4 CH bond. 1, 2, 3, 4. 4 CH bond. And there is one C double bond C. There is only one C double bond C. So, bond enthalpy of 1 C double bond C is 606.10. Bond enthalpy of CH bond. There are 4 CH bond. 1, 2, 3, 4. 4 into bond enthalpy of CH bond is 410.50. And 1. There is only one HH bond. And HH bond enthalpy is 431. Now, adding these three values. If you add these three values, okay. If you add these three values, you will get 606.10 plus 4 into 410.5 plus 431.37. You will get 2679.7. Okay. Now we have to calculate bond enthalpy of product. Now in products, how many CC bonds are there? Only one CC bond. So 1 bond enthalpy of C single bond C plus how many CH bond? 1, 2, 3, 4, 5, 6. 6 bond enthalpy of CH bond. 1 bond enthalpy of CC bond. 1 bond enthalpy of CC bond, and there are 6 CH bond. Now you have to calculate values of bond enthalpy of product. Okay. So it's here bond enthalpy of CC bond is given. Bond enthalpy of CC bond. Please wait. Bond enthalpy of CC bond it is. Bond enthalpy of CC bond is C single bond C is 336.49 plus 6 into bond enthalpy of CH bond. Already we know the value of CH bond. It is 410.50. So you will get 366.49 plus 6 into 336.49 plus 6 into 410.50. You will get 277.799.49. Okay. So we got bond enthalpy of product and bond enthalpy of reaction. So delta enthalpy of reaction is equal to bond enthalpy of reactant minus bond enthalpy of product, and bond enthalpy of reactant is 2679.47 minus bond enthalpy of product 2799.49. Okay, you will get nearly minus 120. You will get nearly minus 120. You will get nearly minus 120, and that is the right answer, minus 120. I think it's clear. You will get minus 120. So answer is clear. Moving on to next question. Answer is minus 120. Moving on to next question. Question number 22. The bond dissociation enthalpy of H2 and Cl2 and HCl are given 434, 242, 431 kilojoules per mole respectively. The enthalpy of formation of HCl. So here we have to calculate enthalpy of formation. What is enthalpy of formation? Enthalpy of formation means it is the enthalpy change occurring when 1 mole of a compound is formed from its constituent element. But according to this equation, H2 plus Cl2 giving 2 HCl, this is not the enthalpy of formation equation, because what is enthalpy of formation? 1 mole of compound is formed from its constituent element. So 1 mole of HCl should be formed from its constituent element. So you have to take half H2 plus half Cl2 is equal to 1 HCl. Now this reaction is formation reaction. 1 mole of compound is formed from its constituent element. This reaction is formation reaction, and enthalpy change of this reaction is enthalpy formation. So we have to calculate enthalpy of formation of this reaction. Now here bond enthalpies of HH, H2, Cl2, bond dissociation enthalpy means it's bond enthalpy. Bond enthalpy of H2, Cl2 and HCl are given. Bond enthalpy of HH bond, it is given as 434. Bond enthalpy of Cl bond, Cl2 bond is given, it is given as 242, and a bond enthalpy of HCl, it is given as 431 kilojoules, right? Now, what is bond enthalpy of, so we can write like this, half into, this is HH bond plus half into Cl bond giving 1 HCl bond. We have to calculate enthalpy of formation, right? Now we know the value, if bond enthalpies are given, enthalpy of reaction is calculated using this equation, bond enthalpy of reactant minus bond enthalpy of product. Now these two are reactants and this one is product, right? So enthalpy of formation is equal to bond enthalpy of reactant. We have to take half because we are taking only half. So it is half bond enthalpy of HH bond plus half bond enthalpy of Cl bond, these two are reactant, minus bond enthalpy of product is HCl. Half, we are taking only half bond enthalpy of HH bond plus we are taking half bond enthalpy of Cl bond, these two are reactant, enthalpy of reactant minus enthalpy of product is HCl, so bond enthalpy of HCl, there is only one HCl. So I am taking half outside, so enthalpy of formation is equal to half, I am taking outside, you will get half, I am taking outside, bond enthalpy of HH bond 434, bond enthalpy of Cl bond plus 242 minus bond enthalpy of HCl 431, right? I think it's clear till here. So enthalpy of formation, first you subtract, first you have to add these two, then subtract this one and divide by 2. Okay, sorry, first you have to add these two, then divide by 2 minus 431. So actually when you add these two, okay, when you add these two, you will get 676. I think you will get 676 something. You will get 676. 676 by 2 minus 431. 672. 4 plus 2, 6. 4 plus 3, 7. 672 by 2 minus 431. After dividing, then subtract, you will get nearly minus 93. You will get nearly minus 93. Answer option minus 93. Answer option fourth one minus 93. You will get minus 93. Minus 93. Not 93, it's minus 93. Answer option 4. I think it's clear. Moving on to question number 23. For the gas phase PCl5 gas giving Cl2 gas plus, PCl3 gas plus Cl2 gas, which of the following condition is correct? So, PCl5 gas break down to form PCl3 gas and Cl2 gas. So, which of the following is correct? Which of the following condition is correct? Now, we know that what is delta Ng? Change in number of moles of products in gaseous state minus change in number of moles of reactants in gaseous state. These two are gases. 1 plus 1, you will get 2. 2 minus number of moles in reactant side. It's 1. 1. That's 1. Right. So, number of moles when reactant changes to product, number of gaseous moles increases. When number of gaseous moles increases, entropy of the reaction increases. When number of gaseous molecules increases. 1, 1. When number of gaseous molecule, here reactant side contain 1 gaseous molecule, product side contain 2 gaseous molecule, 2 moles gas, right? That means number of moles of gas, number of gaseous moles increases when delta Ng value is positive. When number of, that indicate number of moles of product is greater. When number of moles of product is greater than number of moles of reactant, that means entropy of the reaction increases. Right? We know that when solid changes to liquid, entropy increases. When liquid changes to gas, again entropy increases. Here 1 mole of gas changes to 2 moles of gas. Obviously 1 mole is changing to 2 mole, that means entropy increases. So if delta Ng value is positive, that is number of moles of product minus number of moles of reactant, then that means delta Ng value is positive. That indicate number of moles of product in gaseous state is greater than number of moles of reactants in gaseous state. So entropy increases. Entropy increases, which means delta S value is greater than 0. Entropy increase means positive value. Delta S value will be greater than 0. This we have already discussed. Okay. So I think it's clear. 1 mole is converting to 2 moles. Number of gaseous molecule increases, so that entropy increases. Or you can say that when delta Ng value, number of moles of product in gaseous state minus number of moles of reactants in gaseous state, value is positive. When it becomes positive, that means it indicates entropy of the reaction increases. Delta S is greater than 0. Positive. Now we have to calculate delta H. Now here this molecule break down to form PCl3 and Cl2. To break down this molecule, energy is required. Energy is absorbed. Energy absorbed. This molecule absorb energy and it will break down to form PCl3 and Cl2. So energy is absorbed. Energy absorbed means delta H value is positive or delta H value greater than 0. So here delta S value is equal to positive, entropy increases, or delta S value greater than 0. Greater than 0. So delta H and delta S are greater than 0. Positive values. So answer is option 3. Option 3 is the right answer. I think it's clear. Option 3 is the right answer. Why entropy value greater than 0? Because here 1 mole of gas changes to 2 moles of gas. 2 gaseous molecules. 2. 1 is converting to 2. That means number of gaseous molecule increases. It indicates that entropy increases. Or you can also explain like this. If delta Ng value is positive, then that means entropy is positive. Entropy increases. If delta Ng value is positive, then entropy increases. Delta is greater than 0. Positive. Now, this molecule break down to form PCl3 and Cl2 by absorbing. Okay. This is PCl5. Actually, this is the shape of PCl5. This is PCl5, Cl, 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 Cl. Okay, these two bonds undergo dissociation, so it will form PCl3 and Cl, Cl, Cl2. So energy is required to break down these two bonds. So that means delta H will absorb energy. PCl3 will absorb energy. Delta H value is positive or greater than 0. So answer option 3. Moving on to question number 24. Which of the following are not stable? Not state function. Which of the following are not state function? Not state function means the question is which of them are path function. Not state function. There are only two functions: state functions and path function. Not state function means which are path function. Not state function indicate, okay, which of the followings are not state function. That means which are path function. Which of them are path function. Option A is u plus q plus w. What is q plus w? Q plus w is u. According to first law, delta u is equal to q plus w. They have no, okay, q plus w is delta u. Q plus w is delta u. Delta u is change in internal energy. Internal energy is a state function. Internal energy is a state function. Now option B, heat. We know that in thermodynamics there are only two path function, heat and work. Remaining all are state function. So Q is a path function. It's a path function. Now C, work. Work is also a path function. In thermodynamics there are only two state functions, two path functions. Remaining all are state function. Only two path function, heat and work. Remaining all are state function. So Q and W are path function. And third one, this is 1, 2, 3, and fourth one, H minus Ts, right? Fourth one, H minus Ts. Now what is H minus T? We know that delta G is equal to delta H minus T delta S, right? So H minus Ts means, H minus T means it's G. So it's G. Gives free energy. It's a path, state function. It's a state function. Only two path functions are there in thermodynamics, heat and work. So this is state function. This one is also state function. The two path functions are Q and W. 2 and 3 is the answer. 2 and 3. 2 and 3. Answer option 1. Answer option 1. 2 and 3. I think it's clear. This is delta U. Q plus W means delta U, state function. And H minus Ts as D, state function. And 1, 2. These two are path function. Q and W are path function. So answer is 2 and 3. Answer option 1. I think it's clear. Moving on to next question. Question number 26. Given that the bond enthalpies of HH and ClCl are 430 kilojoules per mole and 240 kilojoules per mole respectively, the enthalpy of formation of HCl is minus 90 kilojoules per mole. Calculate bond enthalpy of HCl. So here enthalpy of formation is given. Enthalpy of formation of HCl. Enthalpy of formation of HCl given, it's equal to minus 90. What is enthalpy of formation of HCl? H2 gas react with Cl2 gas giving HCl gas. 1 mole HCl gas. So you have to balance the equation. H2 plus half Cl2 giving 1 HCl. We have to calculate enthalpy. Enthalpy of formation is given. We have to calculate bond enthalpy of HCl. Here bond enthalpy of H2 and bond enthalpy of HH bond is given. Here bond enthalpy of HH bond is 430 kilojoules per mole and bond enthalpy of ClCl bond is, it is equal to 240 kilojoules per mole, right? Now enthalpy of formation is minus 90. We have to calculate bond enthalpy of HCl bond. Okay. Now from this we can write bond enthalpy of H2 means it's HH, but we are taking only half bond enthalpy of HH plus bond enthalpy of ClCl, we are taking only half bond enthalpy of giving bond enthalpy of HCl, and then here enthalpy of formation is minus 90. Here enthalpy of formation is minus 90, right? Now enthalpy of formation is minus 90, right? Here we know the value of HH, bond enthalpy of HH, ClCl. We have to calculate bond enthalpy of HCl. Enthalpy of formation is not. We know that enthalpy of reaction is equal to bond enthalpy of reactant minus bond enthalpy of product. Here we have to calculate bond enthalpy of product. We have to calculate bond because HCl, we have to calculate bond enthalpy of product. So bond and taking bond enthalpy of product to this side. So bond enthalpy of product, here product is HCl. Bond enthalpy of HCl, that is product, is equal to bond enthalpy of reactant bond enthalpy of reactant minus enthalpy of formation, right? Now, here these two are reactant. This one is product. So, bond enthalpy of reactant. Reactants are bond enthalpy of HH and bond enthalpy of Cl. Cl. We are taking only half. So, I am writing half bond enthalpy of HH. These two are reactant. These are reactant. And this one is product. So, bond enthalpy of product is equal to bond enthalpy of reactant minus enthalpy of formation. That is half of bond enthalpy of HH is 430 plus half of, this one is also reactant, half of bond enthalpy of Cl 240 minus enthalpy of formation 90. Now, if you add these two and subtract minus 90, you will get the answer of enthalpy of product, that is enthalpy of HCl. Product is bond enthalpy of HCl. Product is HCl, which is equal to half of 430 plus half of 240 minus 90. So, you will get 430 divided by 2, you will get 2, 1, right? 2, 1, 430 divided by 2, you will get 2, you will get 4, now 3, you will get 1, 1 2s are 2, then you will get 10, 5. 215 plus 240 divided by 2, you will get 120, 120 minus plus 90. Now, if you add these three, you will get the enthalpy of formation of HCl, and I think it's nearly, if you add these three value, you will get nearly 420 something, 425 something, 425 something. If you add, you will get some values nearly. I will check the answer. Answer is 425. Answer you will get 425. 425 kilojoules. This is the bond enthalpy of HCl. I think it's clear. Okay. Here enthalpy of formation is given. Enthalpy of formation means 1 mole of compound is formed from its constituent element. That is 1 mole of HCl is formed from half H2 plus half Cl2. Now, we know that enthalpy of formation, enthalpy of reaction is equal to bond enthalpy of reactant minus bond enthalpy of product. These are reactant. So, bond enthalpy of a half bond enthalpy of HH plus half bond enthalpy of ClCl 215 plus 120 minus bond enthalpy of product, and I am taking product to this side because we have to calculate bond enthalpy of product. So, I am taking minus bond enthalpy of product this side and enthalpy of formation to this side. So, minus enthalpy of formation is equal to minus 90. You will get 425 kilojoules. Answer option 4. I think it's clear. Moving on to question number 27. Identify the correct statement for the change of Gibbs free energy of a system, delta A G system at constant temperature and pressure. We have to identify the correct statement. Now, here they have mentioned that temperature and pressure becomes constant. Now, you should know this thing, that means at equilibrium, all the measurable properties of a system become constant. At equilibrium, when a system attains equilibrium, all the measurable properties, that is temperature, pressure, color, concentration, solubility, etc., everything become constant when a system attain equilibrium. When a system attain equilibrium, everything become constant. Now, here they have mentioned that temperature and pressure, both of them become constant. Temperature and pressure becomes constant. Okay, in question 27, they have mentioned that identify the correct statement for delta G at constant temperature and pressure. Okay, so our system attain constant temperature and pressure. Okay, at equilibrium, all the measurable properties of a system become constant. So here temperature and pressure constant means our system is at equilibrium. So delta G value of system will be equal to 0. So delta G value of our system will be equal to 0. Answer is option 2. Delta G system is equal to 0 and system has attained equilibrium. I'll explain once more. Here they have given that temperature and pressure become constant. Now, when a system reach equilibrium, all its measurable property, temperature, pressure, measurable property means properties that can be measured. We can measure temperature, we can measure pressure, we can measure concentration, we can measure solubility, we can measure color. So all the properties, all the measurable properties become constant when a system reach equilibrium. Now in this question they have given that temperature and pressure of the system become constant. That means delta G value, since both of them are constant, that means our system is at equilibrium. Okay, so delta G system will be equal to 0. You will learn this thing in next chapter, that is equilibrium. You will learn this in next chapter, that is in equilibrium. Okay, I think it's clear. Moving on to next question. Assume each reaction is carried out in an open container. For which reaction will delta H will be equal to delta U? Delta H and delta U value will be equal in which reaction? Okay, delta E and delta, actually U and E are same. Delta U and delta E both are same. So in which reaction delta H will be equal to delta E? What is delta E? Delta E means it is delta U. Internal energy is represented by U or E. Internal energy is represented by U or E. That means it is delta U. So in which reaction delta H is equal to delta U? Now we know the relationship between delta H and delta U. First one is delta H is equal to delta U plus P delta V. Second one, delta H is equal to delta U plus delta NGRT. Now here we don't know the value of pressure and volume, so we are not taking this equation. We can consider this equation, delta H is equal to delta U plus delta NGRT. Now here, what is the value of delta Ng in this equation? Here delta Ng is equal to number of moles of product in gaseous state minus number of moles of reactants in gaseous state. So number of moles of product 2, gaseous state. Number of moles of reactant, both the reactants are in gaseous state, 1 plus 1, 2. 2 minus 2, 0. So here delta Ng is 0. So delta H is equal to delta U plus 0, which is equal to delta Ng is 0. Ng into RT, 0 into RT is 0. So delta H is equal to delta U. So in this equation, delta H is equal to delta U. So answer is option 1. If you want, you can calculate others also. Here, number of moles of gas, 2 plus 1, 3. Delta Ng is equal to 3 minus solid. No, we don't want to consider solid here. This is gas. So 3 minus 2, which is equal to 1. Delta Ng is equal to 1. If delta Ng is 1, then a delta H will not equal to, it will not be equal to delta U. Now, question number 3. Delta Ng is equal to gas 1 plus 1, 2 minus number of moles of reactants in gaseous state, it's 1. Delta Ng value is equal to 1. So delta H will not equal to, it will not become equal to delta U. Now here delta Ng is equal to 2 minus 2 plus 1, 3 minus 1. Here also delta H and delta U value will not be equal, it will not equal, delta H value will not become equal to delta U. Only when delta Ng value becomes 0, when delta Ng is equal to 0, then the equation becomes delta H is equal to delta U plus 0 into RT. So delta H will be equal to delta U. So if delta Ng is equal to 0, then delta H will be equal to delta U. And that is possible in this equation, equation 1. So answer is option 1. Moving on to question number 29. The enthalpy and entropy change for the reaction Br2 plus Cl2 giving 2 BrCl are 30 kilojoules and 30 kilojoules per mole and 105 joules Kelvin inverse mole inverse respectively. The temperature at which the reaction will be in equilibrium is. So here delta H value is given. Delta H value is 30 kilojoules per mole and delta S value is 105 joules Kelvin inverse mole inverse. Okay. The temperature at which the reaction will be in equilibrium is. So here delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T delta S. We have to calculate value of T. Here delta X is S is expressed in joules, so convert delta H to joules. We will get 30 into 10 raised to 3 joules per mole. Right. Now, here we have to calculate temperature, and here delta G value is taken as reaction is at equilibrium, so delta G value is equal to 0. Okay, so equation will become 0 is equal to delta H minus T delta S. I am taking T delta S to size. T delta S is equal to delta H. So T is equal to delta H by delta S. So T is equal to, what is delta S? 130 into 10 raised to 3 by 105. So T is equal to, now when you divide 30 by 10 raised to 3, okay, 30 into 10 raised to 3 divided by 105, you will get 285.7 Kelvin. 285.7 Kelvin. 285.7 Kelvin. I think it's clear. Answer is option 1. Option 1 is the right answer. So here delta H value is given, delta S value is given. We have to calculate temperature when reaction is at equilibrium. Reaction equilibrium means delta G value 0. So 0 is equal to delta H minus T delta S. T delta S is equal to delta H. T is equal to delta H by delta S. You will get 285.7 Kelvin. Moving on to question number 30. The enthalpy of combustion of H2, cyclohexene and cyclohexene are minus 241, minus 3800 and minus 3920 kilojoules per mole respectively. The heat of hydrogenation of cyclohexene is, the heat of hydrogenation, okay, we have to calculate heat of hydrogenation of cyclohexene. The enthalpy of combustion of H2, cyclohexene and cyclohexene are given. We have to calculate the heat of hydrogenation of cyclohexene. That means, what is hydrogenation? Addition of hydrogen. So, to cyclohexene, this is cyclohexene. Cyclohexene. To hexene, we are adding hydrogen. So, these two hydrogen will attach here. So, this double bond will become single bond. This is cyclohexane. We have to calculate enthalpy of this reaction. That is enthalpy of hydrogenation. Addition of hydrogen is known as hydrogenation. To cyclohexene, when we add hydrogen, this double bond, hydrogen will add across this double bond, it will become single bond again. So we have to calculate delta H for this reaction. Okay, I think it's clear. Now here, enthalpy of combustion values are given. What is the value of enthalpy of combustion of cyclohexane is minus 241, right? The enthalpy of combustion of hydrogen is, the enthalpy of combustion of hydrogen is minus 241. The enthalpy of combustion of cyclohexane is minus 3800. And the enthalpy of combustion of cyclohexane is minus 3920. So here, enthalpy of combustion of cyclohexane is given, enthalpy of combustion of hydrogen is given, enthalpy of combustion of cyclohexane is given. Now here there is one twist. The twist is, if enthalpy of combustion value is given and we have to calculate any other enthalpy value, if enthalpy of combustion is given and they have asked to calculate some other enthalpies, here they have asked to calculate enthalpy of hydrogenation, right? So if enthalpy of combustion is given and they have asked to calculate some other enthalpy, it can be enthalpy of formation or enthalpy of hydrogenation or enthalpy of anything, anything is given. If combustion value is given, here enthalpy of combustion value is given and they have asked to calculate some other enthalpies, then we have to use a simple technique to calculate that enthalpy. That is, take the value of product, enthalpy of combustion of product to this side. So we will get minus 3800 minus 21241 and take this value to this side. This is enthalpy of combustion of product and take this value to this side, plus 3920. Okay, solve this value, you will get the answer. Solve this value, you will get the answer. You will get answer, I think it's nearly minus 121. I think it's nearly minus 1 to 1. This is the enthalpy of hydrogenation value. This is the enthalpy of hydrogenation value. This is a simple technique to calculate enthalpy of a reaction. If enthalpy of combustion is given, I'll explain once more. If enthalpy of combustion value is given, first you write the equation. Then below that, write the enthalpy of combustion of reactants and product. Now, if enthalpy of combustion is given and they have asked to calculate enthalpy of a reaction, you can calculate any enthalpy, whether it's hydration or formation or any enthalpies can be calculated from enthalpy of combustion value by taking the enthalpy of combustion of product to reactant side. You'll get minus 1 to 1, minus 1 to 1. You can check the answer. You can check the answer. Answer is option 1, minus 1 to 1. I think it's clear. And this is used only if enthalpy of combustion value is given. This trick is only used if enthalpy of combustion value is given. If enthalpy of combustion value is given and they have asked to calculate some other enthalpies, take the enthalpy of combustion of product to reactant side. So minus value will become plus value. Just solve that value, you will get the answer. I think it's clear. Answer is option 1. This is simple technique. This is a simple technique to calculate enthalpy of reaction if combustion value is given. Okay. Moving on to question number 31. A reaction occurs spontaneously if 4 options are given. I think you remember, we discussed 4 cases when we discussed Gibbs free energy. 4 cases. Case 1, case 2, case 3, case 4. They have given the 4 cases as options. So first option, T delta is greater than delta H, T delta is less than delta H. Here delta H positive, T delta is positive. Now according to Gibbs equation, delta G is equal to delta H minus T delta S. According to Gibbs equation, delta G is equal to delta H minus T delta S. So delta G is equal to, here delta H is positive minus T delta S. Delta S is positive. So delta H minus T. Here delta S is positive and delta H is positive. And T delta S less than delta H. This is delta H is greater than T delta S. If delta H is 5, T delta S will be less than 5. That is 2. Let it be 2. If delta H is 5, delta H is greater than T delta S. That means T delta S will be less than 5. Let it be 2. 5 minus 2 will get plus 3. Delta G plus value means it is non-spontaneous. So this is not the answer. We have to find the reaction in which, when we have to find the condition where reaction is spontaneous. Let us consider this equation. Let us consider equation or not. Let us consider option 2. T delta is greater than delta H. Now we know that according to Gibbs equation, delta G is equal to delta H minus T delta S. Here delta H is positive, T delta S is also positive. So delta H minus T into delta S, both are positive. So equation is like this. And delta H is greater than delta H. Delta H is greater than, delta H is less than T delta S, or T delta S is greater than delta H. So here T delta S is greater than delta H. If delta H is 2, then T delta S, let it be 5, because T delta S is greater than delta H. So 2 minus 5 will get minus 3. So delta G value will be negative. That means this reaction is spontaneous. So answer is option 2. I think we have discussed this when we discussed about Gibbs free energy. There are 4 cases, case 1, case 2, case 3, case 4. I think you remember. So this is the equation. I think it's clear. Here delta H is greater than T delta S. That means delta H minus T delta S. This is less and this is greater. So delta G value will be always positive. But here T delta S is greater than delta H. Since T delta S is having a negative sign here, delta G will be negative. Answer is option 2. Moving on to next question, question number 32. Which of the following pair of chemical reaction in certain to result in a spontaneous reaction? So question number 32, which of the following condition will lead to spontaneous process, right? Already we have discussed 4 cases, case 1, case 2, case 3, case 4. In case 1, you remember that one, right? In case 1, we have discussed 4 cases when we are discussing about Gibbs free energy. So when we were discussing about Gibbs free energy, we discussed nearly 4 cases: case 1, case 2, case 3, case 4. And case 1 is exothermic entropy increases. Exothermic entropy increases. Exothermic delta H value is negative. Entropy increases means delta H value greater than 0, that is positive. Entropy increases means delta H value greater than 0, which is equal to positive. In this case, according to Gibbs free energy, Gibbs equation, delta G is equal to delta H minus T delta H. Here delta H is negative, so it will become minus delta H, and delta H is positive, T delta H, negative H, negative delta H minus negative T delta H, it will become negative. So delta G value will be negative and it will be spontaneous. So for exothermic and entropy increase reaction, delta G value will be always negative, that is those processes are always spontaneous. This is case 1. I think you remember this one. So in this question, which of the following pair of chemical reaction is certain to result in a spontaneous process? Exothermic and decreasing entropy, option 1, that's not the right answer. Endothermic and increasing entropy, that's not the right answer. Exothermic and increasing disorder, that's the right answer. Exothermic and increase in disorder is entropy. Case 1, we discussed nearly 4 cases when we were discussing about Gibbs free energy. So case 1 is exothermic and entropy increases. In this case, always the reaction is spontaneous because delta G value will be always negative. I think it's clear. Answer is option 3. So 32, answer option 3. Question number 33. The absolute enthalpy of neutralization of the reaction MgO plus 2HCl giving MgCl2 plus H2O will be less than minus 57.33 kilojoules, 2 minus 57.33 kilojoules per mole, 3 greater than minus 57.33 kilojoules per mole, 4 57.33 kilojoules per mole. I'll explain that one. Now, what is enthalpy of neutralization? Enthalpy of neutralization means neutralization, enthalpy, delta H, N-E-U-T-R-A-L-I-Z-E, enthalpy of neutralization. What is enthalpy of neutralization? Enthalpy of neutralization means it is the enthalpy change when 1 gram equivalent of acid react with 1 gram equivalent of base. It is the enthalpy change when 1 gram equivalent of acid react with 1 gram equivalent of base. Okay, the enthalpy change is known as enthalpy of neutralization. So enthalpy of neutralization means when 1 gram equivalent of acid, when 1 gram equivalent of acid react with 1 gram equivalent of base, okay, enthalpy change during that reaction is known as enthalpy of neutralization. I think it's clear. It is the enthalpy change when 1 gram equivalent of acid reacts with 1 gram equivalent of base. Now in the case of strong acid, if we are taking strong acid and strong base, if we are taking strong acid and strong base, if we are taking 1 gram equivalent of strong acid and 1 gram equivalent of strong base, then the enthalpy of neutralization value is minus 57.33 kilojoules per mole. The enthalpy of neutralization value is always minus 57.33 kilojoules. If it is strong acid, strong base, then the enthalpy of neutralization value is always minus 57.33 kilojoules per mole. But here, HCl is strong acid, that's okay. HCl is strong acid. But MgO is not a strong acid, a strong base, it's a weak base. So, here, HCl is strong acid and MgO is weak base. If both are strong, then the enthalpy of neutralization value is always, if both are strong, then the enthalpy of neutralization value is always minus 57.33 kilojoules per mole. But if one among them, if either acid or base is weak, then the value will be less than minus 57.33 kilojoules per mole. So here, HCl is a strong acid and magnesium oxide is a weak base. I think you know that. Now, If you don't know the nature of the base, you will study in S block. Magnesium oxide is a weak base. You will study this in S block. Okay. So magnesium oxide is a weak base. When strong acid react with strong base, enthalpy of neutralization value is always minus 57.33 kilojoules per mole. But if one among them is weak, then the value will be less than minus 57.33. So here answer is option 1, less than minus 57.33 kilojoules, because one among them, that is magnesium oxide, is a weak base. So value will be only 6. I think it's clear. You have to remember this. What is enthalpy of neutralization? 1 gram equivalent of acid react with 1 gram equivalent of base. Okay. During that reaction, the enthalpy change is known as enthalpy of neutralization. It is the enthalpy change when 1 gram equivalent of acid react with 1 gram equivalent of base. That is known as enthalpy of neutralization. And for strong acid, strong base neutralization reaction, enthalpy of neutralization value is always minus 57.33 kilojoules. If one among them is weak, then the value will be less than minus 57.33 kilojoules. Moving on to next question. Which reaction with the following values of delta H and delta S at 400 Kelvin is spontaneous and endothermic? So here delta H value and delta S value is given at 400 Kelvin. Temperature 400 Kelvin. Okay. Which condition leads to a spontaneous process? Which condition leads to a spontaneous process? That is, which condition leads to delta G value negative? Spontaneous. Which condition will lead to a spontaneous process? And here one more thing is given, spontaneous and endothermic. For endothermic reaction, delta H value is always positive. So here delta H value is negative. This is not the answer. Delta H value negative, not answer. Delta H is positive. It may be the answer. Delta H positive. So 3 or 4 is our answer, because endothermic is given. Endothermic means delta H value will be positive. In these two cases, delta H value is negative. So answer is option 3 or 4. Right. Now we can use third answer. Let it be, if delta H is plus 48 kilojoules per and delta S is equal to 135 joules Kelvin, then according to Gibbs equation, delta G is equal to delta H minus T delta H. So delta G is equal to, what is delta H? 48 kilojoules. So it is 48 into 10 raised to 3 minus T value 400 into delta S value 135. That is 48000 minus 134 into 400. Now what is 134 into 400? Now when you multiply 134 into 400, you will get 54000. You will get 54000. Now when you subtract 48000 minus 54000, you will get nearly, answer is nearly, minus 6000. Minus 6000. So delta G value is negative. Delta G value is negative. So answer is option 3. This is the right answer. So I will explain once more here. 4 conditions are given, 4 values are given, and temperature is 400 Kelvin, and we have to find the condition where the reaction leads to spontaneous and endothermic. Spontaneous means delta G value is negative. Endothermic means delta H should be positive. In these two cases, delta H value is negative, so these are not the answer. This is not the right answer. These are not the right answers. Now, equation 3. Sorry, third option. Third option, delta H value is positive, and in fourth option, delta H value is positive. So in these two cases, delta H values are positive. That means endothermic. Now substitute equation or third one here. According to Gibbs equation, delta G is equal to delta H minus T delta S. Delta G is equal to 48 kilojoules, that is 48 into 10 raised to 3 minus 400 into 135. So you will get delta G value negative, which leads to a spontaneous process. So answer is option 3. I think it's clear.